And hello, everyone. I think we are live. Let's see if people can hear us, see us. All right. Hello, up here in the corner. Welcome, everyone, to day 6 of the CodeRefinery workshop, the last day of 6 long days of learning about version control. What did we else have? Documentation, AI support for coding, and all those topics. And today we are going to look into automated testing and modular code development. And our first instructors here with me today are Anja and Luca. Hello.
Hello,
From
Hello.
where are you connecting from today?
I'm from Finland. I work as researcher software engineer in Aalto University, so greetings from Tampere.
I also work at Aalto University. I'm on campus in Otaniemi, Finland.
Oh,
Hello.
nice. So we're spread all over Finland. I'm connecting also 1 hour north of Helsinki in Finland today. We are showing currently our notes document for today. So if you have been with us earlier, you know the drill already. We're having the notes document with an icebreaker that we're going to look at now before the hour, before everyone is joining us here. So today's icebreakers are about programming languages and what do you do for testing. So let's ask our instructors. Anja, what is your programming language of choice and what others do you know?
I work almost exclusively in Python because I'm a machine learning practitioner and Python is very dominant there. I've worked on speech recognition and then, since speech recognition also involves a lot of text processing, so I dabbled a little with some old Perl code, and R and C++ are familiar from some courses I took back as a graduate student, but I haven't really learned them. I also only learned the bare minimum to kind of get through the courses.
Okay. Did you learn Python from university or earlier?
Yes, university courses, and then now I did my PhD in Aalto, so I
Okay.
did all my research code basically in Python.
Okay. How about Luca?
Yeah, definitely Julia is the language I'm strongest at, the one I've used the most in my work, in my research. Have been using it since 2019, so when pre-compilation was pretty painful. But other than that, yeah, Python I've used, C++ I've used, Chapel I've used, which maybe not very famous language, but pretty fun language for HPC. A bit of Rust, so yeah, all languages are cool.
Okay. We're seeing people adding their favorite languages or the languages that they are using. PHP, SQL is coming. Fortran, we have some. Very interesting to see always what people are using. Yes, you might see today, and hopefully have seen also in earlier lessons already, that we try to be programming language agnostic. Of course, we have to show like the examples in some language, but for today, for example, you can find in the lesson materials different tabs for different languages. And if your language of choice is not there, but you know what could be like a good addition here, we are very happy to get your contributions for the lessons to show also the testing exercises and demos in more languages than we have right now. But I think we do have Python, R, Julia probably already in the materials.
Yeah.
All right. And then testing. Well, today's topic is automated testing. So what does testing mean for you, Anja? And how do you test your Python codes?
Well, testing for me means kind of maintaining my sanity, so kind of having some sort of reassurance about that my code is actually working as it should. And if I want to change some implementation, then I can kind of do that with more ease and not kind of keep adding spaghetti code in the on top of spaghetti code. So tests allow refactoring your code with kind of this safety net. So you can change your code for the better and then test that it actually still works. So that's the essence of testing for me. And I write my tests usually using PyTest in Python.
Okay. That's something we're going to learn about today. I guess you will be showing a little bit in PyTest, if I'm not mistaken. Yeah, cool. How about Luca? How are you testing your Julia codes, or also any of your other codes, of course?
Yeah, I mean, Julia has this built-in testing library, so I use mainly that for testing, and I mean, similar motivation. That actually, in a way, testing is also a way to, like, since my job is in a way like fixing problems in code. If you don't test your code, you cannot find the problems. So testing is in a way also a way of creating the problems that I have to solve, because it unveils the issues. So it makes a nice circle of life to like write the test so that they break, and then you can fix them. So it's fun.
Do you do automated testing or do you test manually?
Mainly automated also for my open source libraries, which I maintain. I mean, I also test like manually, but generally like my workflow is that if I'm, for example, adding a feature, I start with like a prototype, interactively, checking and running. And then once it somehow works, I crystallize that into a new test, and then I like open, pull a request, and then I run all the tests and check automatically that it passes. So
Okay.
yeah. And these are all concepts that we will learn today, by the way. So if you don't know what I'm saying,
Yes.
you are in the right place.
Exactly. How about Anya? Do you do automated testing? Or?
Yes, I write a lot of unit tests where I can. So, for example, in the old speech recognition workflows, I created all of the pre-processing, kind of making sure that, for example, test transforms work as expected, so that if I get this input text like from some document and I need in speech recognition, all output text is like no uppercase and no periods or any punctuation. So you need to remove those stuff. So testing, for example, that the text is transformed correctly with unit tests. Then I also have command line clients. So I have this end-to-end tests that run some of the command line code and then kind of check that correct logs are outputted and files are created.
Sounds like a really good helper, this automated testing.
Yeah.
How about in collaborative projects? Is it usually you that are doing or implementing the tests, or are you doing it together, or how do you go about it? Luca, maybe.
Yeah, depends. Generally, like the person doing something also generally adds the tests with the something. So at least in the open source projects, where I have collaborated, it wasn't like that one writes the code and one adds the tests, but it's more like that when you add a new feature, when you do changes, you always test that. And then sometimes also there are like pull requests to improve like test coverage, to say, hey, there were some cases untested, here are some new tests. So it's more like preventive, so that hey, this was untested, so it might break with some changes in the future. So now let's, as a prophylactic move, let's add this so that we don't break it in the future accidentally.
Okay. Anya, anything to add?
No, I have little experience on larger projects. My PhD was mostly me working on my own models.
Okay. Are you involved in more collaborative projects now in your role as RC?
No, not yet, but I hope I will get some bigger projects where I get to apply testing.
Okay. We are on the top of the hour, 11 o'clock in Finland, 10 o'clock in Central Europe, and adapt to your own time zone. Very welcome, everyone, to this last day of the CodeRefinery workshop. Today, we're going to take a look at automated testing and modular code development, and we have also a little outro in the end telling you a bit about the CodeRefinery community and also the Nordic Research Software Engineers. So please stay on until the end. We are currently showing here on screen our collaborative notes document. You all got the link to that via the latest emails, or basically everyday emails. This is how we are staying in contact with you, how the instructors can read your questions, and how our people behind the scenes can also help you during the lesson, during the discussions, during the exercises. And on top here, you can see like a bunch of information with all the links you may need today, and also a suggestion on how you can set up your screen. One note here is that Twitch has this wonderful pop-out theater mode feature that you can have really the Twitch screen on one side of your screen and then everything else that you may need on the right side. For example, this notes document. And Luca, let's show briefly how to edit this document.
Yep, sure. So if you browse to the very top of the document, you can see these three icons. And now you can see like the eye icon is kind of selected. So I'm in view mode. So I can only read, but not like modify. If I want to edit, I can select this pencil icon. And then it will switch to edit mode, where I can actually type. So for example, here we can simulate that I can ask, is this a question? And then someone could reply, this is a question indeed. So we can use these for like interaction, like you can with indentation, you can make like a nested list, which is like common practice for answering questions, so that it's easy like to follow the flow of discussion. If you're not editing, maybe it's recommended to keep it in view mode, because it could otherwise introduce some lag also for others if too many people keep it in edit mode. So if you're not editing, good to keep in view mode, but feel free to edit and ask questions whenever you want.
Yes, and this document is completely anonymous. You don't need to log in. So please also do not put any names or other identifying information here. We will publish this document on our event page so that you can also come back later and read any answers and questions. And for now, for practicing, you can fill in our icebreaker. Let us know what is your programming language of choice and what does testing your code mean for you as a starter into today's topic. And now maybe let's ask our instructors to briefly introduce themselves, and then I'll leave you with them for this automated testing lesson. Anja.
Oh, hello, my name is Anja Virkkunen. I'm an RSE, Research Software Engineer at Aalto University, Finland.
And Luca.
Yep. Hello, I'm Luca Ferrante, and I'm also a research software engineer at Aalto University, Finland.
Okay, and then let's go to the event page that you all know from the registration. And if you scroll down here to the schedule, you will find somewhere there automated testing. This is how you get to the materials, and we'll also post in between the links to where we are at the moment in the notes so you can follow along. So have fun and enjoy, and happy learning.
Thank you. So hello everyone, and welcome to the automated tested lesson. So today we want to talk about testing. So why do we test code? How do we test code? And roughly speaking, the structure of the lecture will be the following. So first we will give like a soft motivation, interactive motivation. We hope also to get some questions, comments in the notes, so that we can all chat together as on why do we want to test, how do we test, when is it important, when is not necessarily, what can go wrong if we don't test, and so on and so on. After this short motivation, we will have some examples. So first, we will start with local testing, meaning we will simulate I write some code in my computer and I want to test it on my machine, which is maybe the simplest part of testing. Then we will move to GitHub, and we will simulate, okay, how can I automate this process so that I don't have every time to like run the tests locally on my machine. And then finally, we will talk about test design. So we will say, okay, who said that I need to write a test after I wrote my code? What if I wrote a test before I write my code? Would that be a good idea or not? And we will try to answer that question. And as mentioned before, if you have questions, you can ask in the collaborative notes at any time. Anya and I will try to keep an eye on it and make sure to include your questions in the discussion. Nice. So without further ado, let's go to some motivation. What is the importance of testing? What is the idea of testing? The idea is that when code is difficult to write, and it's very easy to do the wrong thing, and it's very easy to have uncaught edge cases. It's very easy to have tricky corner cases that you don't think of. So writing code is often like an adventure. And whenever you change code, it often, especially in bigger projects, it becomes almost like a butterfly effect. So you change some part in the code somewhere and something else, and it affects the behavior of some other part of the code in an almost apparently unexpected way. The idea of testing is to make sure that things which are working keep working and don't accidentally break when you change your code. So this is like the one motivation of testing in a nutshell. Make sure that the things which are working keep working whenever you change your code. Then do you have, Anya, anything to comment, to add, you want to ask?
Yeah, I would add also this thing that testing is also kind of gives you a peace of mind, so that, for example, if you find a bug in your code and it breaks your code, then you write a test to fix or ensure that that bug doesn't reappear. So you kind of get better software in the long run. So you find a bug and you ensure it doesn't reappear with tests.
Yeah, there was a question in the document. Are we talking about testing or automated testing? Maybe I was a bit sloppy in my notation, like wording. But now for this motivation, we talk about testing in general. So we want to motivate testing in general. Then we will talk about automated testing in 2 chapters from now. Excellent. So, and so here we have a short snippet. And as we were saying, like we try to be language agnostic, but we cannot do the exercises in all different languages. So for this lesson, we will mainly use Python for testing. However, for almost each example, you have alternative in C++, R, Julia, Fortran. So for example, if you're interested in seeing how you would do the same in C++, you can always switch tab and check how the C++ version would look like. And I think we have them for almost all of them. I think I found a couple that were missing Fortran maybe, but that doesn't matter. Yeah. Yeah. So, yeah, and here basically we have the discussion what we just said, that what is the purpose of testing, like preventing, preserving what works. So make sure that what works keeps working. This is especially important if you're collaborating with other people, because sometimes, especially in bigger codes, not everyone can be aware of everything. So maybe if you're collaborating in a bigger project, you don't even know that some code exists in that project. And if when you do your changes, that change might unexpectedly affect also others people contribution to the same code base, which you didn't even know existing. So testing makes sure that whenever you add features, whenever you do changes, things that work keep working, so that you don't introduce what we call regressions. Yeah. Yeah. Another thing, which is another, I would say, maybe side effect of testing, let's put it that way, is that if you're new to a project, testing is looking at the tests is the one of the best ways to learn how to use the project, how to use the new code. So you are starting to, let's say, for example, contribute to PyTorch. You are very into machine learning, you took your classes, you took the CodeRefinery class, now you feel super ready to contribute to open source. You go to PyTorch and you want to know, okay, but how do the internals of this PyTorch work? Looking at the tests is generally the best entry point to start also contributing to open source projects, because by definition in the tests you need to use the code that you're testing, so it shows you how the code is used. So it's also a good way for entry point.
Another way to look at it, that it is another form of documentation.
Yeah.
To have tests of your code.
Yeah, excellent. Then playing a bit devil's advocate, when do you think it's okay to not add the test? Like, let's say if I do a do you think sometimes some changes can be small enough that it will be pedantic to add a test, or is there a thing as too many tests? What do you think?
Well, tests are a lot of work, so I understand the kind of temptation to skip tests. I would personally skip tests if there is already if I'm using some other library, so of if that library is already tested, I don't really write tests to ensure that that library works. But I would only write tests for my own code.
Yeah, that's a very good point, that if you use some dependencies, as we talked like on Tuesday about dependencies, you don't need to test those again, because you can assume they have been tested already in general. What about this example here, like a short, obviously correct Python script, which you never intend to reuse? A short, obviously correct script, presumably in this case that you intend to reuse, since it doesn't specify otherwise. What do you think of these cases? Do you think both are okay to not test, or would you test either of them?
Yeah, that's kind of a hard choice because you can never actually be sure that you will never reuse some bit of code. But if you're pressed for time, then test writing takes time, so it is kind of understandable that you skip testing if you're, for example, still prototyping or making some early versions of some code.
Yeah, totally. What I would comment is like the obviously correct. Like I like that it has quotation marks, because it's obviously correct until it isn't generally. So it's easy to say, yeah, this is obviously correct, I can be sure. But sometimes, like it happened to me many times, like, yeah, I don't need to test this. It's like, it's obvious. It's like one line change. It's doing what it's doing. Of course, I don't need to test. But then it turns out it was like a bit deeper than that, and there were like issues. So I always like when things are obviously correct, because whenever I say, this is obvious, I don't need to test it, within like a couple of weeks I generally have to eat the crow and realize I was wrong, and yeah, it's fun. Yeah. Another thing I was thinking is that sometimes there's a lot of things I can test, like especially if you work with numerics, with like numerical algorithms, you cannot test your function for all floating point number. If you use 64 bits, it's like 2 to the 64, which is a lot of numbers. You cannot literally test your function for every single input that your function can take. You need to be a bit smarter than that. So I think this has like two aspects that you need to prioritize when you write the test. You need to think, what is the most meaningful input I can use for testing. For example, maybe one case of like some simple like usage, and then a few corner cases. But I would consider redundant. For example, if I have a function that adds to number, I wouldn't test with like 20 different integers the same function, but I would take like some quote unquote normal integers, and then maybe try to think, okay, what are the corner cases that I'm not thinking? What are like the difficult cases? But I think like when writing tests, you need to have this kind of like smart, like hacker, like hat on, that you think, okay, like I cannot test for all the inputs. How do I choose the inputs for my test? How do I choose what inputs I test? What are like the tricky ones, the difficult ones? And sometimes it's okay to miss those. I'm not saying you must always think to those ahead of time. I've seen like in open source projects that sometimes there's like, code with some tests, and then I find a bug. I was like, hey, for this special case, it's not working. Like, oh, thank you very much. Now I fix it and I add a new test for this corner case, which I didn't think about. So it's difficult. Yeah. Okay, let's before moving to the vocabulary, let's quickly check if there are some questions in the chat. Sometimes I that I wrote some script, but then trying to make it reusable requires much more thought than just writing it. Then if I'm not going to reuse it, what's the point of adding automating tests? Yeah, that's a good point. Like if I'm not going to reuse it, why would I test it? If it's something that I need only once, if I need to, okay. So I was looking at the questions. If it's something that I'm going to need only once, for example, now I needed to rename these 10 files and never do it again, then the test is have I successfully renamed these 10 files? So I think this is like a valid point, that if it's something that you never use, it's something like some dirty code that you write for once, then yeah, why should you add a test on that? Yeah, but then also if you're going to rename 10 files, do you actually want to do it with your real files? Aren't you afraid your quick scripts might accidentally delete the files? I mean, if you know what you're doing, no, that's okay. But then maybe you want to say, okay, now let me try with a couple of smaller files. And actually in this trying, you are actually testing already your script. If you try with some like fake smaller data before trying with the real data, just that you say, okay, I need only once, I do the quick test, then I use it, and then I don't need it again, so I don't crystallize my tests somewhere. But you're still testing. Unknown inputs and check visually that it does not fail and that it gives the expecting results. Is this testing? That's I would say this is maybe borderline between prototyping and testing, because so I think there's a lot of things to unpack here. You say you check visually that it does not fail. When you say check visually, what does it mean to check visually? Because maybe you say, okay, I check that the number is right, but when you say you check visually, you realize you rely on how the computer shows you things, and how the computer shows you things is often different from how the computer handles things internal. An example is floating point number, also known as decimal numbers. On the screen, you see 1.1. Behind the scenes, it's actually a bit trickier than that. It's not exactly 1.1. We will have a small test about that. So when saying that visually, just check visually that it works, I would say it's a great starting point, and it's also how I start. I start prototyping and I check, yeah, this kind of makes sense. But I would say checking visually is great starting point. Maybe I would call it more like prototyping or like drafting tests, because the way you check visually is different from the way the computer checks things. But yeah, this was very good question, and definitely I would say great starting point. That's also how I start, like in Python or in Julia, you have interactive. So I run the code like in the interactive shell. I see what it gives. I'm like, yeah, does it make sense? Does it not make sense? Yeah, looks like it makes sense. And then I write the actual test, the stricter check, and I realize, actually what I was seeing was only the tip of the iceberg. There's like some more complex things.
Yeah, that same has happened to me too.
Yeah.
Like I was talking about the text transforms earlier. So first I was just eyeing through the like output transforms, and I usually just check the one I the latest transform I added, but the chain of transforms actually, the order of the transforms in the chain mattered. So then I would miss some other changes in how the kind of output change, and then automated testing kind of saved me from that.
Yeah, great. All right, then maybe we can move on. Okay, I see like a fun question. Do reviewers ever even have the time to review the code? I mean, it depends on the reviewer. Some have, but it reminds me of a meme which I saw on internet that if you ever meet a bear in the forest and you're afraid, just ask the bear to review your pull request and the bear will go away instead of attacking you because you asked for a review of your code. So, yeah. Okay, back to serious stuff. Yeah. Okay, so next we can see like a different type of testing. So now we say we only said like tests, but actually there's a different type of tests. And throughout this lesson, I would say when we say tests, we will mainly actually mean unit tests. But just to be aware that there's more type of tests that you can have. So unit tests, which is what informally we will just call tests mainly during this lesson, are in a way the basic tests that you have. So for example, the tests where you test the functionalities that you wrote. So, you know, you implement a function and you write a unit test for that one, for that new function, or you write multiple functions and like unit tests for those multiple functions. Then sometimes though, if you write a library, your library is not meant to be used alone. It's meant to be used with other libraries. For example, what could be a good example? If you think of NumPy, the Python library for arrays data structure, that's not meant for people to just write arrays for fun. That's meant to be used, for example, as part of PyTorch, of TensorFlow, and so on. And so NumPy developers want to make sure that their library, their functionalities does not break other libraries that rely on that. This is very important for core libraries, like for example NumPy. Imagine if NumPy breaks something accidentally, then all the machine learning libraries in the internet fall apart. And these are called integration tests, sometimes also upstream tests, where the idea is that you don't check only your functionalities, but you check how your functionalities work together, either multiple functionalities of your library or how your library works with other libraries. So that's also, it becomes important if you have, when you have a big open source project that a lot of people rely on. It's not just testing your functionality, but testing will it break libraries that depend on my library? Like example NumPy. Imagine if NumPy suddenly messes up the vectors so that, I don't know, you cannot index from 0 anymore or something like that. It breaks the indexing and you cannot index NumPy arrays anymore. Imagine what happens to all the linear algebra and machine learning libraries. So integration tests are this one. Yeah. Yeah. Then sometimes so we have like regression tests are I would say it's a bit like so this terminology is also, you know, a bit like blurry line. It's not like the absolute truth, but in general, like when we talk about regression tests, for example, they are related to performance. So if we want to check that if our code is performant, relevant, so for example of NumPy or linear algebra libraries, it's important that matrix multiplication stays fast. So checking that the change does not make, for example, performance worse of our code. It's another type of test, and that's also tricky sometimes to get right. Yeah. And then the other are concepts that we'll briefly like cover during this lesson, during the automated testing one. So this continuous integration, code coverage, testing framework are things that we'll talk later. So I'll leave them for now. Cool. Let's check. Yeah. Okay, cool. Then I think we can move to the next session. So we did a lot of talking. Now it's time to do some testing, actually testing some libraries. So I'll move to the next section, this testing locally. Yeah, and here actually we will start with a small example where you will be asked to to write a small Python function and then write a test for it. And as I was mentioning before, here during the demo, so when Annie and I will go through the exercises, we will use Python. But if you want to use R, Julia, C++, you are free to do that if you want so. And if you use Python, we will use this library called the PyTest, which is the one, and I would maybe the most popular, Python library for testing. So it's a testing framework. So a library which offers functionalities for tests. Yeah. Yeah. And
Luca,
so here
is this now, what type of test is this
I
regarding the
would
previous vocabulary?
Yeah, excellent question. Yeah, I would definitely call this integration test. Yeah. No, sorry. What am I saying? Sorry. Morning. Unit test, of course. Yeah, sorry. Yeah, we definitely call unit test. So here you ask to write a small function and a small unit test for that function. And then you're asked to run it. And then the fun part, to break it, because the purpose of having tests is to break those. If they never fail, they're not fun. Yeah. So maybe it's 26 past the hour. I would say we could give maybe 10 minutes
Yep.
to this, and then we will be back at, or like to make round numbers, I would say we're back at 36 past. Yeah, so see you back at 36 past in 10 minutes. Bye.
Bye.
Hello.
Hello again.
Welcome back. So I hope the test, the exercise went well. Now we will go through the solution. Before going through the solution, just a minor logistic announcements that if you are in edit node in the collaborative document, please make sure that you don't have accidentally test selected, because unfortunately it will, if you select some test to copy paste a link to read them for whatever reason, it will stay like selected forever. And it's very, very easy to accidentally delete it if you then press a key on your keyboard. So please, if you are in edit mode, make sure that you're not accidentally selecting. You don't have any text selected. You should be able to press ESC or like click somewhere the cursor, and you should undo that. Yeah, thank you. With that being said, now we will go to the solution of the exercise, and to do that I will change the scene and share my editor so that we can chat about the test. Okay, can you see my text editor now, my VS Code editor?
Yes.
Okay, excellent. Now, perfect. Now, what we want to do is that we want to check the exercise. So we were asked to write a simple function which adds two inputs. So def add return a plus b. Oopala, sorry. And then add a simple test. Now, there's a couple of things to unpack here, which are important to highlight. First of all, I'm using this naming convention, which is test underscore add. So what I'm doing is that I'm defining a function which contains all the tests. So I check that add 2, 3 gives 5, and add spaceship gives spaceship. So the reason why I'm doing that is that we want to use PyTest, and this is the standard convention for using PyTest. So you must you must put your tests into functions, and you must start the name of the function with test underscore. Why? Because this way PyTest will find it on its own, and we'll be able to run all the tests, as we will see in a second. So now I saved this file, and now
Luca,
if we
does the, like after the test underscore, does the remaining, does it need to kind of match the function name that I'm testing? So
no, I think you can you can change that. It will maybe be a bit nastier. We can try in a second changing it. It will just change the name, but because you can test also other functions here, you could also check other things. So yeah, now we can test it. So now I'll go to the terminal and run PyTest.
and what is assert?
Oh yeah, assert is asserting that the expression returns true. So basically what it's doing is that, so here we can put whatever code, but this code should return a Boolean that is either true or false. And this assert is checking that it's true. So here the instruction, we have the function add 2, 3 equal 5. So this equal in Python is checking equality. And so here we're checking that when I call the function add with inputs 2 and 3, then the result will be 5. Yeah. And similar here, it checks that when I call add with space and ship, the result will be equal to the string spaceship. So if you didn't know, in Python, when you just do plus operator, if it's numbers, it will do the addition, the like elementary school addition, so to speak. If it's strings, so like text, it will concatenate them, so like attach them together. So that's why space plus ship, it's called spaceship. Yeah. And now if we run the test, you can see like it ran 0 items because I did it wrong. So if I just, I needed to tell PyTest what file to run in this case. So what we want to do is that we want to do PyTest v, and now my file is called example.py. Yeah, and it says one test passed, test add passed.
What should I look at in this output? What does it tell me?
Yeah, so a good rule of thumb when testing is that if you green good, no further reading needed, red bad, needs reading. So the way my my like programmer brain works is that I see green, I'm like, oh, it's green, I don't need to read, and I switch off my brain. But now if I try to be a good person and actually read it despite the green, here I would say these are like details which are not necessarily like that important. But now the important part here I would say is like this here. So collected one item, it means that it found one test because we only have one function called the test underscore add. And now what it's saying is that this test underscore add, so the item which it found, it passed with 100%. And then one test, so one item passed in how long time? So 0.07 seconds. Now we can try different variations. So let's change this test here to do 6 instead of 5. So now this is wrong. 2 plus 3 should be 5. And let's run it again. Oh, and now you see red. Yeah. So now let's see. It says that the test add failed. And now it's giving us some details about what failed. It says that, okay, this expression, so it's highlighting the expression, add 2, 3, 6. And now it says, hey, this assertion 5 equals 6 failed. So this is a nice thing that it kind of executes the expression step by step. And it says, hey, now I got this 5 equals 6. And this 5 came from the function add. And now this failed because 5... Sorry?
Does it execute also the second assertion?
I think it fails fast in this case, so it stops at the first assertion. We can verify it. So if I change this and change spaceship to spaceship, yeah, so now I definitely executed the first one at least, but it doesn't print
correct.
information about the assertion. I think because this is kind of atomic unit, so it checks that the function passes as a whole. It doesn't like differentiate between individual ones. So if you wanted to have more granularity, what we could do is that we could split these in test add numbers, test add strings, and then we would have more granularity on how it goes. Yeah. And in this case, it highlights that, okay, spaceship and spaceship is not the same string, and it's, I guess, somehow highlights the difference, tries to highlight the difference between the strings. Not sure if I find it very readable. So maybe before moving on, let's try what you just said. To like you say, okay, but now I have 2 within the same function. One passes, one doesn't. I want to have more control. I want to understand better if it's a problem with numbers, with the strings, or with both. So what we want to do now is that we want to split this function into 2. So I will call it test add numbers, and I will keep this one. And then I will define a new one, test add strings. Apparently I have some AI feature enabled in VS Code, which gives suggestions. Sorry for that. Okay, so now we split that into tests because we want more granularity, more control on the reporting. And now we can run again. And now you see, okay, passed, that we say add the numbers passed and add the strings passed. So both passed. And all good. Now let's try to do the same ablation study of before. So let's break one. So now choose 3, return 6. And now we say, okay, one failed, one passed. And now we can see, okay, that the other strings passed, but the test numbers failed with the error that we saw before. Yeah. And now if we did some more radical change, for example, we mess up the function itself, add, instead of doing a plus b, we do a minus b. Oh, wow. So apparently, I don't know what that is. I think it's my Python extension in VS Code. And apparently, it's automatically on the background running the test and showing that this is going to fail and it's going to be -1. But it doesn't find it for this one. I don't know. This is pretty cool. So I don't use VS Code in my like day-to-day workflow. I use this only here for teaching. So I didn't know about this feature. I don't know what this is, but looks cool. But now, since I'm old school, I will still run it from the terminal. And now we see that both tests failed. Yeah, and so like this is like the kind of same error. Now, maybe one thing to briefly mention is that now the second test, the one about strings, fails in a deeper way, so to speak. So it's not just about returning the wrong value, but it's actually about the operator minus not being defined for string, so actually throwing an exception. So that's also like something good to highlight, that tests can fail for two reasons. Either because it returns the wrong value, so you know like the code does run but it gives you a wrong answer, or because it throws, so there's like a deeper bug in the problem that makes your code throw an exception, so panic, so to speak, say I don't know what to do, I'll just scream in panic, so to speak. And I would say that in general, like the cases where the test throws are more serious, but I generally find them also easier to debug, easier to figure out, because I have like a clear issue that okay, now it throws, and often it will also tell me like what if I have like longer code, what smaller part of the code, what function causes that issue, and it's easier like generally to figure out. Whereas if it's only the wrong answer, it could be there's like a silent failure, so like a sneaky failure somewhere, and that can be trickier to find. So generally when my code throws, when my test throws exception, I'm happy because I know it's like messed up big times, but I know that it will be easier to figure out the issue. Whereas when it's the wrong value, I know it's like more subtle issue to debug. Nice.
So what do we do next?
Yeah, I think this is a good moment to check for questions in the HackMD.
What do you say about this? What is the standard directory structure for test units? Create a test or tests folder in root or right next to your. So now we have the test function in the same Python file as the function we are testing.
Here it is. Yeah. Great question. So I would say it depends a bit a lot on the language also. I would say for Python, it's maybe also what the answer highlights that there's like this test directory in the root, which has all the tests. It's the same for Julia. I'm not a Rust developer, but to my understanding, maybe someone who's Rust can correct me. For example, in Rust, they put unit test in the same file of the source code. So that's also another approach which I've seen in Rust code. Not sure.
Yes, that's the same impression I have from seeing Rust code.
Yeah, but I would say this test folder is the most common one. Maybe also in JavaScript, I've seen like test, I think in TypeScript, I've seen like test file and source file in the same directory sometimes, not sure. Oops, I'm not screen sharing. Okay, yeah. But yeah, cool. Comment breaking test typically means to break the code. Yeah, that's true. We wrote two separate test functions in this example. Is this the best practice usually, or is it just unit testing? Yeah, great questions. I would say that it depends. So you want a balance of how granular you go. Like, suppose if we look at this example, if I started to check assert, for example, add 0, 0 equal 0, assert add 1, 2 equal 3, and so on and so on. I would say in this case, I don't necessarily want to break this in 3 functions because, well, I definitely don't want to break this in 3 functions because because they are basically follow the same logic. So I think you need to find the balance for and depends a lot on like on the project you're working on, but you want the balance between like granularity and grouping things together. Then there's like a good question that I mean not in the notes, but a question we can ask: does it make sense to add these test cases like 0, 0 equals 0, 1, 2 equals 3? Once we have 2, 3 equal 5, I don't think adding these adds much value. Like if I wanted to add more tests, what I would do in this case, I would add more examples to check for overflow. So if you don't know what that means, it's not important. But basically what I mean by that is that there's like an edge case where if you add to positive integers, it could become negative, and it's called like integer overflow because it's, you cannot have all the numbers on a computer, it's a finite, and if you kind of like overflow and get back to negative. So I would check for these I would check for these like edge cases. So like in general when I write the test, I like basic case and then edge cases. And as I said before, sometimes I cannot think of the edge cases, and then I found out the hard way.
What about negative integers in this case?
Yeah, I mean we could add one. I think if you're in doubt, add it. I wouldn't say maybe for this function is that interesting, unless you had your own custom implementation of addition. But in general, yeah, it's like a good way of thinking when you test with numbers: case positive, case negative, case 1 is 0, and so on. Yeah, there's a comment I really like. I'm actually scared of even touching the tests after I've written them. That's like a good, I think it's a good point when you say like fixing tests. You can always you can change the tests, or you can take the test as untouchable. And that's also like a bit of like fine line that sometimes if you update the behavior of your code, the tests become legitimately outdated and you need to update those. Whereas sometimes updating the tests can mean to hide the issue. Say, yeah, now I'll update the test to behave this way because that's what I get from my code. Like test, copy paste the result and say, okay, now I tested. The test does what I got without thinking too much. So it can happen. Cool. With this chat being said, now I think we can move to the next part, which is automated testing. And we are almost at the hour, so should we have like a break now? Or,
yeah, everything.
Okay, cool. So we will have now a 10 minutes break, and then we will come back for the part about automated testing. And if you want so the next part will be on GitHub. If you want, you can of course just like sit back and watch the demo. If you want to follow, I've created a small repository that you can use. It's empty at the moment, but you can fork the repository and then clone it, and then you can work on that repository.
Where
So
are
let
you
me
going
share it.
to share it?
Yeah, I'm putting the link in the notes. Okay, I see Samantha typing, so I'll just put the link here and I let her do the typing around it.
Okay, so 10 minutes break.
Yeah.
Bye.
Bye. Hello,
Hello.
welcome back. Hope you had a nice break. So now we are going to move to the internet, so to speak. So far we have only tested locally, but now we will in a way actually harness the power of testing. So I'm not going to say that if you only test locally, tests are kind of useless. They're still useful, but automated testing and on CI is where the power of tests actually come to life, where you actually see why tests are important. So to demo this, I've created a short repository before the break.
Can you also show from the lesson material where we are at right now?
Yeah, sure. So now we are going into the next session, this automated testing. And to do this demo, I've created a small repository. So I put the link in the collaborative document. So it's example CI, simply called. And if we look at what this repository has, well, at the moment, it's kind of a good example of bad practices. It has an empty README and two simple files. So this functions.py, which contains some functions, and test functions, which contains some tests. And now you see actually the first one is what we had before. Now, the idea is that this is now open source project and everyone can contribute. Everyone can propose changes. Like everyone can say, hey, you are doing your code this way, but I think you should do it that way. Or if I have issues, so I see I need help with doing this and that, everyone in the world can jump and start helping. That's the cool thing of open source, that you don't need to ask for permission. You can just do it, as long as you're polite, of course.
So
However, yep.
You can continue, I'll ask.
Yeah. However, with great powers come great responsibilities. And imagine if this were like very popular repository and I got 10 pull requests a day or 100 of pull requests a day. So like 100 of change submissions, change suggestions per day. It would be very, very painful for me to every time check the change the person made, run the test locally on my machine. If you followed Git, this would mean that I would need to check out their branch, run the test on their branch, and so on and so on. It would be a lot of manual work, and I would argue like lead to the open source developer like getting exhausted and giving up. So we need a more robust way, and the magic word here is automatic testing and CI. CI is short for continuous integration. And what I want to do, I want to make sure that whenever someone proposes a change to my code, I can automatically run the tests so that their change is tested, and I can directly check a report like, is everything green? Are there some breakage? And if there are some breakage, some tests fail, the person can automatically work on them without me having to point them out. So that's the power of automated testing and CI, keeping open source developers sane. Connects to Anya's first answer today, that tests are to keep your sanity. So how do we set it up? Now, I'm going to show here that's not something that you need to remember by heart by any mean. There's like a bunch of like tools for doing it. You can check in the material.
Now my question here, I'll inject. So now you have functions.py and test functions.py. So previously we had one file with the function and the test. So how does this test functions.py differ?
Yeah. So like
functions?
the idea here is that we are playing that we have a bigger code, and keeping everything in a file would be unergonomic. So that's why we have moved it to a different file. But from a automation point of view, it doesn't differ. PyTest still checks for files which are called like test underscore something and executes those files. So it's just like for modularity. We'll talk about code modularity later. It's like to make the code more modular. As a rule of thumb, when things grow, you want to split. Start with one file. Now pretend the functions.py is big, and then you don't want to keep a lot of code and a lot of tests in the same file, so you want to split.
And I would like to add here that now you need to import your functions to the test file.
Oh yeah, totally.
To be able to test them.
Yeah. So now I'm going to show you how to set up the actions following the example in the material. One thing I want to highlight is that if you start developing a library, there's a good chance you will never need to do what I'm doing here, because actually now most programming languages have a lot of templates for library structures and that allow you to automatically set up the structure of your library. So you don't need to think, oh, do I put the test here? Do I put the test there? Do I need my CI? How do I write it? Someone does the thinking for you and you get ready. Actually, when I started the open source career, so to speak, I think I was 1.5 years like developing libraries without having no clue what the CI was doing. It's not great, but you can survive. Okay, but now if you have forked the repository, you can go to actions. Yep. And now since this is a Python library, you want to select this Python application. Okay. And now this what is doing, this is preparing a change. I don't know if I can make this, if I can collapse this. I hope it's readable. Let me know if I need to zoom. I don't think I can collapse this, unfortunately. But so basically, this is a YAML file. And basically, this is declaring what needs to be done on every pull request, for example. So it's saying this action needs to be executed on main and on pull requests. So whenever someone opens a pull request, I need to execute these actions. And what do I do? Well, without going too much into details, what I want to do basically is that I want to execute the test. And then I'm just going to do a couple of small modifications. So here under permissions, I'm going to add pull requests write. I'm going to explain in a second why I'm doing this. One thing I want to highlight is that if you write YAML, this YML file, is very sensitive to indentation. It's even like stricter than Python in a way. So always be careful like that the indentation is correct. Like if I wrote like this, it would probably break. You see now it's red. So be careful with indentation when you write YAML. Yeah. So this, I'll come back to this in a second. Then if I go here I'm installing all the packages that I want for my library, for my action, and I'm going to add one called pytest-cov, which is to generate the coverage. So the coverage, what it does is that it prints a report of what lines of my file are covered by the test. So I can see file by file, is this line covered by the test? Is this line covered by the test? So I can graphically see in my code what parts of my code are covered by test. And the purpose of coverage, of course, is like to show off that you have 100% and get a shiny badge on the README. No, just kidding. It's like to make sure that you cover all the tests. But it always looks nice to have a cool badge on the README. And this is why I was adding this pull request write. So this is allowing the action to write to the pull request. And the reason I'm doing that is that I want this action to post a comment on the pull request showing me how the coverage changes. So that is there like an increase in coverage? So if the person adds test, the coverage should increase. If the person adds a new function untested, the coverage would decrease because now I have more code which is not tested. And pull request writes says, okay, you are allowed to post a comment on the pull request. By default, it's off for security reason, but you can allow this action to post comments. And the final change, and now this I'm just going to copy paste from the material and then explain briefly. Yeah. So now I modify. Before it was just calling pytest. Now I'm passing these arguments to basically tell it that hey, also compute the coverage. So calculate the coverage of the files while you run the test. And this last step, what it's basically doing, it's basically uploading the coverage so that it can post the comment. So it says, if you are on pull request, execute this action. So this is like another action which posts the comment with the summary of the coverage. Like these are all details. I don't want to go too much into details. You can be happy even without knowing, but if you're interested, to give some details. Now that we have our action,
so where does this action go? Where is it saved?
Excellent question. I'll show in a second when I merge. So let's just push to main directly. And now we see, if we go back to the repository, we see that now there's a new folder called .github/workflows, and this is where the action goes. So if you did it manually, you would have to create a folder called .github, because you are in GitLab, and a folder called workflows. I think it's a bit more relaxed, that you could put the workflows, so like the actions, also elsewhere, but this is like the most common one. And now we have this Python app.yaml file, which is like the action. But most importantly, if you noticed before here, I had like a yellow dot, and that yellow dot meant now I'm running the action. Now it's green. And if I can check the details, what happened here is that it ran the tests. So you can see here we say, hey, test functions.py 100%. So the test passed.
So how can I navigate to these actions in other way? So there is the check mark, but how can I else find it in the GitHub UI?
Yeah, like to be honest, I use the check mark most of the times, but also from actions here, you should be able to see like the recent actions that you run. So yeah, but I think most of the times I use the check mark, or most of the times I look at actions from pull request. So now let's have a brief example to demo like the power. So what I will do now is that I will open a pull request to my repository, pretending to be someone else and doing a batch change. So what I will take the functions.py, I will click the pencil to edit the file, and then I will change this add from being a plus b to be a minus b. And now when I do commit change, I'll create a new branch and create a pull request. I will call it modify add function and add a description. This is totally like it. You can merge. So now I'll propose this change, create the pull request. And now something cool happens. You see we have this yellow dot, so now the action is running. So now the tests are automatically run, and now we get a red check because the change was breaking the code. And now, so this is actually, so regarding Anya's question, how to interact with actions, this is also like the most common way. And now I can click this. And now I say, okay, test with PyTest failed, and here we get the report.
What are the other steps visible in this output?
Yeah, so basically here you see all the steps of the like action, but I don't, so here like where you install, so when we did pip install PyTest and so on, setting up Python, these actions checkout is basically some setup of the actions. Actually don't even know what it does exactly under the hood, but it works. Yeah, so you see all the steps that you have in the YAML file. These correspond to what you had under steps, and you can in theory expand, but in general there's like one that you care about, which is this test. Yeah, and now since it failed, it also failed to create the coverage. And now this way I can catch up catch early and in more robust way failures. And so I can keep my sanity as developer because all the tests are automatically tested. And even though now I was being a bit maybe like sassy with like the comment, this is not only for malicious, like defense, of course. Even when I commit to my own pull request, sometimes I make mistake, and it's good that I can make pull request, run the test, meanwhile work on something else, then check the result, fix that, run the test, work on something else, and so on and so on. So this is was like a very brief motivation for GitHub Actions. In the teaching material, there's a few more examples. So if you want to follow the steps, you can try making the pull request, uncommenting other tests, fixing those, and so on. But now we will move to the next section. Yeah. Okay, so I'll go back to the material. And now we will go to test design, which is maybe my favorite part of this lesson. So far we have first written the code and then written the tests. Now what we are going to do, we are going to do the other way around. So, and we will do it straight with an exercise. So what the idea of test-driven design is that the tests are not just to fix issues. Tests are not just to correct, to improve, or to defend. Tests can also shape your thinking and can be like the driving force. Tests can be specifications. So in test-driven design, the tests are the specifications you start with. So when you think what you want to code, you crystallize your thoughts, your requirements into test. So here we have this quote unquote famous example of a FizzBuzz where you want to write a function which takes an input, a number, and then if it's divisible by 3, it returns fizz. If it's divisible by 5, it returns buzz. If it's divisible by both, it returns FizzBuzz. And the catch of this exercise is that you don't write the function first, but you first write the test. So in practice, what you will do, you will create a file. You can do in only one file, FizzBuzz, and then first you will define the function test FizzBuzz with defining the test, and then you will start implementing your function and make the test pass one by one or all at one if you manage. So that's the idea of the exercise. Is it clear? Implement this FizzBuzz function, but first write the tests and then start writing the function. And when we will go through the solution together, we will also explain a bit better, like test-driven design, what is the power, and so on. So maybe we can give 15 minutes for this part, I would say. So please create a file and create a function test FizzBuzz and the function FizzBuzz. First write the test, then write the function, run the test to pass the function, and so on.
Okay, happy testing. Bye.
Yep. Bye. Hello and welcome back. So now we will go and check. So now we will talk a bit about the test-driven design, and we will go through the solution of the exercise. So in the exercise, you were asked to implement the typical FizzBuzz function that maybe you have already implemented in some programming classes. But the catch here, the twist was that you were asking to first write the tests and then write the function. So in a test-driven design. And the motivation of that is that you first specify the tests. So your tests work as a specification of your program. Your tests tell you how the code should behave, and then your work is not to like well, it's still to write code, of course, but it's not like, to design the function, but to work towards, or well, not to think what the function does, but work towards making the test pass. Because when you think what the function should do, you crystallize that into tests. So your tests become the definition of what the function should do. And then you work towards making those tests pass. And now here we have a simple skeleton. So here I have the FizzBuzz function. And in Python, there's this keyword pass, which basically means, nah, I'll do it later. So it basically means, this is not doing anything, like whatever. And then we have the function for testing, which is also like as a skeleton at the moment, just saying assert true. So now if I run this test with ptest v FizzBuzz, it very dumbly pass because the test is only checking it's true. So the test is passing, we are done. Bye. No, just kidding. Now we can start thinking. So, okay, I want to define this FizzBuzz function. And the first thing is that I look at the specification. It says, okay, if it's divisible by 3, it should return fizz. If it's divisible by 5, it should return buzz. If it's divisible by both, so if it's divisible by 15, it should return FizzBuzz. So the first thing I could do is that I could write some simple tests for this case. So assert FizzBuzz 3 equal fizz, assert FizzBuzz 5 equal buzz.
There is 3S in assert.
Oh, yeah, I do a lot of typos. Assert FizzBuzz 15 equal FizzBuzz. So those are like the simplest cases for the like kind of 3 first bullet points of the specification. And we're like, okay, so if it's a 3 should return fizz, if it's 5 should return buzz, if it's 15 should return FizzBuzz. And now we can run the test again.
I would like to add that this is why you need the skeleton for the FizzBuzz function. So, and having the pass statement there, because otherwise, if it doesn't have a function to call these tests, won't work.
Yeah. I mean, now they don't work either because now it says they fail. But yeah, if I didn't have this FizzBuzz at all, they would still fail the test, but they would throw because the function would not be defined. Yeah. Okay, now we can, so now there's generally like 2 ways of test-driven design. One is that you try to think of all possible cases and write all possible tests. I mean, you'll never write all, but as many as possible. Another one is that you break it into milestones, into smaller milestones, and you write a small batch of tests, make your function work for those simple cases, and then you start build on top of it. So for example, if I look at what I did here, now I'm not considering cases where, for example, the number is 7, so not divisible by any of those. I could like take into account it here, or I could start working on these test cases and then expand on top of my function. Maybe I will add the case of 7 because it's fairly easy, but then we can start building on that and building those. So it says that in other cases, it should return the number itself. So I will do assert FizzBuzz 7 equals 7. Now there are, if you look at the instructions, there are other cases. So if it's like a non-integer or 0 or negative, it should fail. So it should probably raise an exception and so on. But I think now we have like a good batch for starting working. So now what we have done, we have written the tests, we have written some tests, and we have some specifications of how our function should behave. This is a bit like function interpolation, that now you define some points for your function, and you kind of make sure that it works for those points, but then you could have undefined behavior in the middle. All right? So now let's start implementing our function. Okay, so we have n, which is an integer, and now we start saying, okay, if n is divisible by 3, then return fizz, for example. And if n, sorry, what am I doing? So what am I writing here? So n, oh, shut up, n percentage 3 is the remainder. So if the remainder of dividing n by 3 is 0, so this basically means if n is divisible by 3, return fizz. So if the remainder of n by 3 is 0, return fizz. And if you're thinking, wait a second, that's not how I would write the code, that's not the right order, please bear with me, like it's we'll get there. Okay, so if it's divided by 5, return bus. And if it's divisible by 15, return fizz bus, else return n. So now we have some definitions of our function. So now the workflow is we wrote the tests, which are like our specifications of how we want the function to behave. And now we start working on it. We start working towards passing those tests. And how do we start working towards passing the tests? We start writing the function. Yeah. So now I can run the tests. And we can see that we are not quite there yet. So why? The issue is that, okay, now here for fizzbuzz 15, it was expecting fizzbuzz, but actually get fizz. And now this is something that happened.
Okay. Oh, you're back. You were lost for a second. We lost you at.
If it will happen again, I'll turn my camera off to save bandwidth. But yeah, so I was saying that now we see one test failed because when the input is 15, it was expecting fizzbuzz, but it actually got fizz. And this is something that happens in test-driven design, that you write your tests, you start working towards passing those tests, and you don't pass all of them at once. So what is the issue here? The issue here is that we check this condition in order, and if a number is divisible by 15, is also divisible by 3. So 15 returns true already here, and that's why we return fizz instead of fizzbuzz. So how I want to check it? I want to basically switch the order of this condition. So if I want to first check if it's divisible by 15 and say return fizzbuzz. Otherwise, if it's divisible by 3, return fizz. And now the order of 3 and 5 doesn't matter because they are coprime, so they are mutually exclusive, these two branches. Now, of course, like, fizzbuzz is basic exercise. I knew by heart this is the right order, but I wanted to demo something that happens typically in test-driven design, that you write the tests, you write your first implementation, and your first implementation is not good enough. Your first implementation has issues. And then when you do test-driven design, you run the tests and you see, oh no, I was wrong. And then you can come back to the implementation and debug. So now we have done this, and now we can run the test again. And now we see that everything passes.
But what about the edge cases?
Yeah, exactly. So now, yeah, so you mean like at the other cases, or start to expand the behavior?
What happens with negative input?
Yeah. Yeah, excellent. Yeah. So now we have a basic version, and maybe say, okay, we have this done, and now I can go for coffee. I come back from coffee and I say, okay, but have I actually considered all the cases? What if it's a negative input? I say, okay, assert, fees buzz, and then I say, okay, wait, what should it do for 0? Well, the instructions say that 0 should fail. I would say 0 is divisible by 15, but it doesn't matter, I guess. Let's do what the instruction says. So it says, okay, what should I do if the what should I do if it fails? I want to check that it returns an assertion. I want to check that it throws an error. Okay. So for example, I want to throw a value error if it's a negative number or 0. And the way I do that in PyTest is that I use this special syntax with pytest.raises, for example, value error fees buzz 0. So this is a bit like a special syntax, but what this is saying is that, okay, if the number is 0, then it should raise a value error, okay? Because we had in the specifications that we want to do this, okay? So now let's run the test again. And now we fail. We fail, but not for the reason I was expecting, though.
You don't have
It's
input.
okay, but this can happen, of course. So what happens here? It says, oh, PyTest not defined. Why? Because I forgot to load the library. So here we can do import PyTest. This is also something that happens in test-driven design. You start typing and then you realize you forgot to type something. Okay, and now we get something more meaningful, which is failed did not raise value error. Unfortunately, it doesn't show us the output. It's a bit disappointing. It would have been nice to show. But now we see, okay, now for this case, it doesn't work because it doesn't show me the error. It doesn't raise the exception. So we say, okay, now we have new test. Now we need to extend our function to take care of this case. So now what we want to do is that maybe we want to extend here that if, so let me just write like this for a second. So if the number is smaller or equal than 0, then we want to raise a value error. And I mean, now this is not a Python course, so it's not important if you don't know the like syntax, but value error input must be positive. Okay. So this is how in Python you throw this value error, this exception. Now we can run our tests again. And now it passes. So now we take care of this case. And now we can say, okay, 0, but what about -1, -2? Well, we can add here other cases. So we can do another block with pytest.raises value error, for example, fees buzz -1.
Yes, and I think for PyTest you need to have separate with clauses for
Yeah,
each
I believe
test. You
so.
can't put these two tests in the same with statement.
Yeah, we can try it. I think it needs to be separated. Not sure. So we can quickly simulate it. Let's see what happens. maybe I'll make sure I put something that should break, so I'll put a 4. And now this should not pass because 4 will not rise. Yeah, it passed, which is very worrying because it means it only runs the first one and ignores the second one. Yeah, so interesting. So yeah, we need the separated one. This is also something very thematic, I think. Know your test framework. Like if you're using PyTest, like now it fails because I have this FizzBus 4. But before it wasn't failing because if it were multiple statement, it was only running the first one and that was passing. And this is something very thematic. Always know your test framework. There's this this expression in Latin, which I don't remember anymore, but it's something who watches the watchman. So sometimes you need to test your tests. So like what I did here, when I put here 4 instead of -1, I was actually testing my test. So I was checking if now this should fail. Does it fail? It didn't. Okay, so that's not how we use the test. Yeah. So we're getting towards the end of the time. Hope this was a very short short introduction to test-driven design. Hopefully you got a overview of the scene of the motivation. I don't think it's important like to know all by heart now all these like small nuances like pytest.traces, percentage for division and so on. What I wanted to convey is the idea that in test-driven design, you first write the tests as specification and then you work towards passing the tests. So towards like achieving your specifications. And if you look at the tests that we wrote here, we did it in 2 steps. First, we wrote this test and implemented the function. Then we added more tests and expanded the function. Now, we could have also started with all the tests, so like writing all of these, but sometimes if you write too many tests at once, it can also feel a bit too overwhelming because you start thinking about taking care of that case, and sometimes it can be easier to go incrementally. Get the basic version, test it, add more tests, expand on it. So just write the tests before the implementation of what you are testing. But sometimes also breaking the test in smaller batches can help for like cognitive load and like mental bandwidth to like not get overwhelmed. Yeah.
Should we now go back to the notes and look at any questions? There is still.
Yeah, I will switch back to the notes. In which case it's better to start with tests. So like it's not like a rule. So if you work as software engineer, sometimes the company has rules and then you follow the rules of your employer. But that side apart, I would recommend if you have never done it, try it at least once. So like next time you write some function, try for fun, test-driven development, like for for your personal research project or open source projects. If you have never done it, try it for fun, and then see is it something that grows on you. Do you feel it clicks to you? Like it's not compulsory to do it. It's one approach. It's not objectively accepted by everyone in the world. That's the only approach. So try it and see like does it help structure your work? Does it help you think in a more structured manner? If it does, great, do it. If it doesn't, then don't do it. But in the end, it's it's something that should feel good for you. It depends on your workflow and the way you work on cognitive aspects like way of approaching problems, way of thinking, and so on and so on. So that's my answer. When to use accept and when to use with pytest.trace. I think this was like answered. Assert is for checking the value. Raise is for checking that an exception is thrown. So exceptions are a bit like strange in programming languages. They're not just values. They behave slightly different because they interrupt the program. So you need to catch them in a way. So you need some extra like infra shenanigans. You cannot just check exception equal that one, because when you return an exception, it actually like kind of kills your program, halts your program. So yeah. But yeah, with that being said, here we really only scratched the surface. If we show the PyTest, which is great if you use Python. If you use Julia, there's different like testing environment. If you use C++, there's different one, and so on and so on. So in terms of like conclusions and recommendations, always always check what the person next to you is doing. When you start in open source projects, always check what are others doing, what other tools are people using, how are people doing pull requests, and so on. So always get the lay of the land, watch what other people are doing.
Yes,
And
in big open source projects, you can go
yeah.
find the tests. Where are they? What do they look like?
Yeah.
Also, we didn't go through every material on this lesson, so there are more exercises you can work on your own time.
Yeah, totally. So hopefully now you know why you should test your code, and how some basic idea of like what type of tests you have, how you can test, and so on. And with that being said, I will head back to Samantha for the outro.
Yeah, we're actually not going to have a full outro right now because we still have one session coming up in the afternoon about modular code development. But thank you so much, Luca and Anya, for guiding us through automated testing. We hope you got something from it, or if it doesn't feel relevant for you, then also know that our lesson materials will be and will stay available for you. For now, we'll have about 1 hour break. We'll be back at 1 o'clock Central European Time, 2 o'clock Finnish time here on stream, then with new instructors, and later a bit longer outro with some more information. Keep the questions coming if you still have some in the notes, and see you back in about 1 hour. Bye.
Bye.
And welcome back, everyone. So after this break, we will talk a bit about modular code development and how to make your code more reusable, partly for you, partly for others, and to avoid having to re-implement the same things multiple times and to having to rewrite the same codes multiple times. We'll argue a bit as to why this is good, and we'll give a code along session. So, or not a code along, code along if you want, but mainly implementing your comments on how we can achieve these kind of things. So, this lecture will essentially, before I forget, actually, probably should do a small introduction. So, I have been teaching before, but just as a recap, I'm Thomas Pfau I'm a research software engineer at Aalto, and Frankie, can you
Hello,
say something
yes,
about
I'm
yourself?
Frankie Robertson. I'm a research software engineer at the University of Helsinki. And yeah, so with this, I mean, I'm quite excited. I think we're going to find out, we're going to kind of put this into practice because a lot of the time, modular code, good practices, this sounds kind of vague. So we're going to kind of try and talk about the things in the abstract a bit, but then try and show what they look like in practice on an example.
Yeah.
Yeah.
So, and we will be starting with essentially some example code in a notebook that Frankie can show now.
Okay. Or were we going to look at this first? Okay. Yeah.
Well, we can start. We could also start with the image, which is essentially the problems that
I quite like it.
that will will happen to a lot of people when you don't think a bit about the way you are designing your code, where you have the problems of hidden dependencies, where you have some library pulling in things and it's not being made explicit, and you fail because there is some maybe even hardware dependency that is not mentioned anywhere, and that's essentially a blocker for anyone wanting to reproduce it. You have a lot of times, and that is probably where modular code development actually gets its biggest use. You very often see duplicated code. So you have the same code multiple times, and if you find a bug, you have to fix it in all the duplicates.
Yeah, so
And
these are
that,
kind of related. And it's
yeah,
also related to long functions and kind of modularizing long functions. There can be sort of hidden duplicated code when you have kind of long functions, things that aren't obvious, but then can turn out can be factored out and become useful utilities throughout your code base.
yeah. And one of the other problems with long functions is also that they start to become unreadable. Because in the end, you don't even know anymore what was actually the target of the function. The code might be necessary, but if every bit of code is in that same function, you can't really follow the steps anymore because it just gets too complex.
And I think this feeds into this idea of self-documenting code. So when we split code up into functions, we can give each function a name, and we can try and design each function so it has a clear purpose. And this kind of ties also with having clear variable names. So having clear variable names, clear function names, clear module names. If we think about the structure of our code, we can maybe make it so it's easier for people to approach, more approachable.
Yeah, and also modularization helps to some extent to avoid this overcomplicated design problem, because if you have clear code parts, clear distinction between different responsibilities in your code, it's much clearer how things are going to get called. And you are not getting into, okay, I need this and that, and how do I get? You can kind of talk through through any functionality quite easily.
Okay, so let's start to put it into practice then and look at our example. That's not there. It's here. Yeah.
Yep.
Okay, so What is this? What are we going to do?
So the example that we're using here is a relatively simple weather data plotting script.
Okay.
There is in the repository that is being used here, there is some data from the Finnish Weather Observation Service.
Oh yeah.
And the script that's in the repository is essentially taking the data, doing some pre-processing, like what's happening with a lot of a lot of data that we are getting in science, that we first need to do a bunch of data pre-processing, cleaning up things, and so on.
This is always the first step.
Yeah. And then essentially takes the data and plots some extracts. And
Okay, so yeah.
there is actually just saw it in the notes as well. There's also now a comment or question whether modular code is more testable, and I would say definitely, because under certain circumstances. So if and that's where if you could scroll down a little bit later, there's talk about pure functions. If you have pure functions, yes, those are definitely better testable than if they are separated into individual functions than if you have a long script. And it becomes a bit more difficult if you have functions with side effects, which there very often are. But on general principle, I would say, yeah, more modularized code is better testable because you can test individual functionalities more easily. Okay, so how are we going to go through this code? Well, or we can just
Should we
have a
should we
quick
take a look? Shall we say kind of line by line what it means? Maybe I can say what I think's happening.
Yeah.
So here we're importing these libraries. This one's for dealing with like table-like data called data frames, pandas, and this one's for plotting matplotlib. So these are very commonly used libraries in Python. And then here we read in our CSV file. So we read in a table, and here we're taking these individual columns and we're combining it into a column for the date and time called recorded at. And we set this as an index, which allows us to use this special type of indexing, which allows us to, in pandas, conveniently take out a whole month. And then we do this. This is quite a common pattern that to start a new plot in matplotlib, we call this subplots, even though we only have one plot here. And we get a figure and axis object. And then we plot the air temperature using the index on the x-axis and the air temperature on the y-axis, put some labels and colors. And then we take the y values here, and we take find the average y value. And then we add onto the same axis a horizontal dashed line for the mean temperature. And then we set up some labels here. And then we improve our x-axis for dates. And we save that plot, and then we're going to make another plot. And it's pretty much a similar idea, but this is for precipitation, this one.
Yeah, and we will later go through this and try to modularize that, reduce the amount of code that we have actually written here, probably by quite a bit, and make it shorter. We also will generate code so that we can that it becomes more flexible, so that we are not stuck with, okay, anytime we want to change to a different month, we need to take out our whole script, modify it, and rerun the whole script. We essentially can just give the month somewhat as an argument to what we want to do. Okay. So what I think we should be doing next is for the next, let's say, 15 minutes, so till 25, any classrooms can head into discuss that themselves, and we will have a discussion here
Yeah.
about what modular code is, what
Yeah.
what different ideas people have on this.
So if classrooms want to mute the stream, now is the time until 25 past, right?
Yep.
Yep. Okay, so and we'll also now we'll have a discussion, and we're also going to be checking this hedge doc. So you see here in the hedge doc, these questions have been put there: B, C, A, B, C, D, E, F. So let's have a read of these. So the questions are: should we go one at a time, or should we read them all first? What do you think?
Let's give it 2 or 3
Okay.
minutes to see if people start writing things there.
Okay.
And
Okay, so well,
then
let's read the questions. So the questions we're putting to you is, what does modular code development mean for you? Code development mean for you? What are best practices can you recommend to arrive at well-structured modular code in your favorite programming language? Because there can be different facilities and capabilities for modularizing code in different programming languages. So we're trying to focus on things that are pretty commonly available in this lesson, but it is true that you might split things up differently in different programming languages. And then what do you know now about programming you wish someone had told you earlier? You know, kind of related to this modular thing, but just in general too. Do you design a new code project on paper before coding? So how much should we plan top down the structure of our program beforehand, or should we kind of go in and iterate? We'll be taking quite an iterative approach in this lesson, but it is also possible to kind of come up with a design beforehand. Do you build your code top down, starting with the big picture, or bottom up, starting from components? So this is kind of related, but it's actually a bit different. Discuss pros and cons. So this could be like if you know you're going to need a certain utility function or something, you just code that first. Whereas top down, you might try and, you know, whatever the main thing that your thing does, that you try and build that kind of all at once. Would you prefer your code to be 2 times slower if it was easier to read and understand? And this is quite an interesting question because, yeah, definitely depends, right?
And we get the first answers in, and
Okay.
I think we can just now start essentially from the beginning. So,
Yep.
What does modular code development mean for you? I'm pretty much on code that on par with parts at least of the answers here. And this, yeah, writing code can be split into standalone sections. Yes, that is very much what modular code development is about. So that you essentially, for me, it's distributing responsibilities of what I want to do. So that somewhat would be my answer to number 3, where you have a bit of the question, but how big should the blocks be? I'm thinking of it as I want to have a certain responsibility. I want to have a certain responsibility for one function. And if that responsibility becomes too large, then what I would on tendency do is I would keep the responsibility still in this function, but I would create sub-functions. Like essentially a bit going into management. So one function is the main manager, and then I have my sub jobs that I distribute to additional people, and in the end I need to combine this again. So that's a bit my approach, how I would think about at least handling code modularity. What about you, Frankie?
I think, I mean, how big should a box be? It's how long is a piece of string? Unfortunately, it is one of those types of questions because it'll definitely depend on your problem. You know, sometimes there are natural ways to break down a problem and break things down. Sometimes, like, we just have to kind of artificially a bit you know, some things are difficult to break down, and it's a bit artificial the way we break things down, but it can still be useful that you end up with units that you can keep in your head. So sometimes it's much more natural, I think, where module boundaries lie, and other times you have it can become a bit labored, and sometimes like it's maybe you just have to like have quite a large module because there's a certain amount of irreducible complexity. So I think it can vary quite a lot.
Yep.
Yeah,
I
so
would
yeah,
generally agree.
yeah.
But yeah, let's head on to the next one.
Yeah,
What
I
best
think
practices?
I'd like to call out this though, clarity of mind. So it's to do, yeah, I think it is to do with your mind, what fits in your mind, and what you can understand. Okay, yeah, definitely. Okay,
Yeah,
so best
yeah.
practices.
So to arrive at well-structured code, I think the first yeah, the first two are actually very true. So having a in general well-structured or a template or
Mm,
directory structure that reflects what you're doing,
mm,
where you have essentially modules within your code that are responsible for certain parts. So if you have a more complex system, you might have a module for algorithms where different algorithms can be used for different functionalities. And
mm,
then I would essentially put all the different algorithms that solve a specific question or a specific kind of problem into one folder,
yeah,
um, or one module in that case.
yeah. And I think there's
And
talk of, yeah, sorry.
yeah, but sorry.
Yeah, okay, so sorry I think this template thing is sort of like conventions here, right? So they're talking about having a directory template. So if there's a lot of if you're building something that's similar to a lot of other libraries or something like that, and there's a established convention, then there's certainly something to be said for following the existing convention. Um,
Yep.
yeah. So, and then we're talking about sketching out the architecture first. I mean, yeah, this can work sometimes when you know what you're building. But then there is this question in research software, right? Do we always know what we're building? Do we know how it's going to end up?
Which is essentially what's currently being written there. Reassess the structure that you have made to see if it still fits your actual problem that you
Yeah.
want to solve. Um,
Yep.
then, but given the time, I would say we head on
Okay.
to the next one.
Yes.
So for me, what do you know now about programming that you wish somebody told you earlier?
Hmm.
For me, uh, but that is probably my problem.
Hmm.
Asynchronous stuff.
Okay. Yeah.
That's because I'm now working a
Yeah.
lot with web things,
Yeah.
and everything is essential, or a lot of things are somewhat asynchronous, and it's very often way more efficient to run things asynchronously if you don't care when it is being done, but only
Mm.
that is being done. But
Mm.
that's something that probably for scientific computing is not that important most of the time.
Yeah. Um,
What about you? What's something that
yeah.
you would
I'm.
have liked to know earlier?
I'm not sure if there's any. It's always. I mean, like you're saying, this is something you know for a particular project or particular genre of projects. So there's definitely a lot of small things. It definitely happens though. Yeah. If I had known this, I would have designed this differently. Maybe let's look at some of these. So functions are not fancy stuff. They're essential to properly structure your code. I mean, that's
Yep.
true, and we'll definitely be looking at that. I mean, that's the um, simple functions, be as organized as possible. Yeah, be deliberate and plan in advance. Yeah, it's definitely when you can, it's better to have a proper plan. Having a test suite for easy maintenance. So I guess that was this morning. Um, and then use version
Version control
control.
for personal code.
Yeah,
Yes, use version
yes,
control for any code is, I
yeah,
think, I luckily was told that relatively early on during my studies, but yes, it's definitely a very important factor.
yeah.
Um, do
Mhm.
you design new code projects on paper before coding? I sometimes sketch things on paper before if it's really more complex.
Okay.
before I
Yeah.
actually start with any code, because
I'll
it
be-
helps
I'll- yeah.
visualize visualize the interactions and helps
Yeah.
visualize what I mentioned earlier, the responsibilities of individual parts of what I'm doing.
I'll be honest, I really don't like for the layout of code, no. But I mean, a paper comes out for algorithms and stuff like that, and for the modeling, and I kind of think that changing it's become like changing code is cheap, like so. But
Yeah.
I mean, eventually it's not cheap. If you get stuck into a bad architecture, then eventually it can become a pain.
I think for me it has started primarily when working more with servers and setting up services where
That makes sense.
you just need to think about things. Admittedly not so much while I was doing more sciencey things, because the structure is very often relatively clear from the beginning. Relatively.
I mean, yeah, I would say I do tend to do something a bit like we're going to do today. I start with something that's, barely modular, and I modularize it as I go, kind of as I see the need arising. Maybe just a bit too late sometimes even, and I find that works kind of okay because I find that way I know where the needs are, what modules are needed, kind of as it comes out of it.
So about the
yep.
question was building your code top down
Okay.
or bottom up, so from components to things or to big picture. I still tend to very often, even for larger things, I get a larger design, but I will probably start implementing with smaller things in a more or less bottom up approach.
Yeah.
Once I have the general idea.
Yeah. So you have a top-down plan, but then you implement bottom-up kind of thing.
Yeah. The main reason
nice,
is because that way I can start testing individual things relatively early on, or at least easier, and can start to make it to more easily have some kind of integration between the different parts, integration tests between the different parts. While if I would start top down, I could still do unit tests for every individual call, but I would need to mock so many things underneath that I am essentially implementing everything 4 times.
Yeah.
Yeah,
a mixture of both too is yeah, definitely. What do you think about this? Would you prefer your code to be 2 times slower if it was easier to read and understand?
So, this is a very good question, and to me, part of what I am as an RSE, from a scientific point of view, the most important bit to me is that my code was understandable and that it worked. So yes, I would prefer it to be 2 times slower and easier to understand, because if I want to kind of productize that, or I need it faster because otherwise I don't get the stuff finished, I can still do some kind of optimizations, run things. Normally, I would agree with the thing that it should be a way not to sacrifice performance over readability, but that can become difficult. Python is somewhat of an approach, or does somewhat have an approach to do that, or an attempt to do that by, well, we are writing it in Python and we are calling C libraries underneath for the heavy lifting. But I would honestly say I'd rather have some code being slower and better maintainable. And if I need it faster, I can still have, okay, this is the working version. I'll write a few tests for that, and now I start to optimize things.
Yeah.
But that
I mean,
would be my approach.
it's not often that the trade-off is exactly this clear, I suppose. Yeah, it really depends, but I mean, I don't know. I like trying to get stuff to run fast sometimes, and it doesn't always mean that it's got to be unclear. I think when I go in and optimize stuff, that's when and try and, especially if I try and change the algorithms, that's when I like produce like some notebooks or something to kind of show what I'm doing. That's when, so I feel like, yeah, I mean, it puts more burden on me to explain what's going on. In that case.
One approach that I have done a few times is if I start to optimize, I will take the original lines that I had there, put them in a comment, essentially indicating this is what the next bits are supposed to do, because then I kind of have it in a clean way written down. This is what's happening now, and then there is the optimized lines of code that are difficult to understand because they are not intuitive or make use of some kind of fancy reallocation or whatever of things.
Yeah, you can.
I mean,
sometimes you can keep your slow implementation and you can test your fast implementation against your slow implementation. So it's not a either or necessarily.
Yeah.
So your questions continued. Shall we just field these questions briefly?
Let's have a quick look.
How do you define responsibility? I've heard the definition, a reason to change. Do you like this definition?
I'm admittedly not entirely sure.
Right.
So for me, responsibilities is things like if I have an algorithm that does a certain functionality that, for example, determines optima, that is a function that in itself is a function call. There might be subparts of that, like mean, like some other algorithmic approaches that this algorithm calls, but
it's like purpose. Responsibility is purpose. It has a single purpose. So you can say single responsibility, single purpose.
Yeah.
I have personal experience with badly designed architecture inherited from other colleagues. Yeah. So do we all? I wish people would think about what they're doing before inserting random patchments. True. Left with legacy code and legacy language cannot be migrated to another system. Okay. Well, this isn't a question. This is a gripe. Yeah. We've been there. I mean, we have to find a way forward. What would you say about security issues? Should we learn about these things before writing code? I mean, I would say, like, if you're exposing something on a network, then maybe you should worry a bit about it. But depends.
Security is a really, really difficult topic, and I would be happy to come back to that in the discussion session later. But I would like to skip that at the moment because it's a huge topic for itself.
Yeah. Okay.
So, but I think the classroom should be back by now as well. And we can essentially now go to encapsulation a bit. So what encapsulation is?
Oh, we're going to encapsulation, are we?
We can have a quick overview of what it is. So encapsulation. Could you zoom in on the right side, Frankie?
Yes.
Thanks. And for some reason, your screen, or at least what I see, is a bit cut off on the right side.
Whoopsie.
Okay.
Accidentally resized it.
So encapsulation is something that we have essentially heard in the comments quite a bit already. It's isolating individual functionalities so that they are not interacting with something outside. That can be either from the external environment, that can be within a function, that can be on a lot of different levels. And the more encapsulated functions are, the cleaner they commonly are, the more likely they are pure functions. Because as soon as a function modifies something and doesn't modifies something, you can always get into the problem that this is an unexpected behavior. Because what you see very often is that you hand in some object and you get some object back. And if the object that was handed in is then being modified, then you are not sure, okay, what is this actually?
So to define what a pure function is, it's like a function in mathematics. So it means that the output depends on the input, and you can kind of, if you keep calling the function with the same input, you're going to get the same output. And the input isn't modified, and nothing else happens apart from returning the output, strictly speaking.
And I think, well, the important bit, the input is not modified.
Yeah, yeah.
That is because even if a function does return one value only, if it modifies something of the input values, this is a non-pure function. And
Okay.
yeah, that's I think as much about
That's what we want to say. Yeah.
encapsulation that I really want to say here.
So let's go to this exercise. No, it's not this page. It's this page.
It's
This page. Let's look at this code again. Back to the code, and I'm going to put this in a notebook, right?
Yep.
Okay. And if you want to code along, now is the time to code along. Or you can just watch. So it's modular. I'll just call it modular. Okay, so I've made a directory, and then I'm going to activate my Conda environment. So I'm going to activate my CodeRefinery Conda environment. Okay, so I've made a directory, cd'd into it, activated the CodeRefinery environment, and now I'm going to do everything for this in Jupyter Lab. So now it's opened up here. And then what should I do now? I'm going to make a notebook, right?
Yep.
Okay.
Actually, let me just check one thing. Yeah,
Yep.
okay, yep. Just make a notebook, copy that code, and we also need to obtain the actual data file then. Because running this now would not do anything because we don't have the weather data.
Let's get this. Okay, so here we go. I'm going to go up here. I'm going to right-click this. I'm going to right-click this raw one. I'm going to copy this link. I'm going to go back to my terminal. I'm going to go, oops, I'm going to use bash. And I'm going to go to CodeRefinery. And I'm going to go to Modular. And I'm going to grab this using wget.
An alternative, if you are on a Windows system, you can also just download the file and upload it in Jupyter Lab. That
Okay.
is maybe the simpler option. Essentially, if you go to the file over, I think it's the file overview.
Right here.
Yeah.
And then
there is an upload button in the upper
this.
in the middle thing where you can just select the file that you downloaded and upload it into this folder.
Oops.
So, okay, let's see what this code does if we actually have the data. Let's run it.
Yes. Okay, here we are. Here's our plots. Okay, so it seems to work. So we're done.
Yep. If we only ever want the information for January, then we are done. But this is not what we actually expect that we want. So let me play, or let me or the or our listeners now play the supervisor. So this was your first job. What do we want to do now? I would say could you also show me the stuff for February?
I just go in and change this probably here. Okay, done. All right, I'm clocking off. Cheers, boss.
Okay. Yeah, wait, but I would like to have all the plots at the same time, please.
Oh, no. Well, okay. Now, I think maybe what I could do is I could try and use a loop, right?
Yeah, for example.
Okay. Oh no, look here, like here I saved it, even though it's February, I saved it as January too. Okay.
Yeah, great. So
Okay.
my January stuff is now messed up. What can I do with that now? Okay, so
Okay.
let's see, how can we build this so that we actually can change this a bit more easily. So what do we had look earlier what we are actually doing, and I think what we need to change to do it for any month
Okay.
somewhat is, yeah, well, we could first write a for loop that essentially
Okay.
goes over a set of months.
Okay, let's do that real quick. Just because, I mean, you know, if
but
this is simple, this could be enough. So
yeah, at least for
let's just
January and February.
okay, so I go here, and then I think the cool thing about this loop is, you know, this takes us part way there, but also this we can kind of reuse what we do here with this loop, because now we're going to find all the places where we're using the month.
Mm-hmm.
So we also use it here. So here I'm going to use an F string to put the month in.
Mm-hmm.
And I've just pasted it in there. And here I'll find another F string. Okay. So now I've shown them both. Oh no. What have I done?
And there's
here.
also, just as an information, there is now in the collaborative document a section for interaction possibilities for the audience. So where you can tell us what to do next. It should be in the very end. And there is a suggestion for plot multiple data month.
Okay. Well, I kind of like this, that it's doing exactly what we're asked to do. It takes a list of months and it plots for all the months. But on the other hand, I wonder what the natural unit is here. Is it natural to plot it for all the months at once, or is it more natural to plot for just 1 month? Because now it's like the single responsibility idea. If we have a function for all the months, this function is doing two things. First, it has to concern itself with plotting just a single month, and then it has to concern with, well, just doing them all, but it could involve collating the results or something else. So it's nice, but I might prefer to make a function with less responsibilities. What do you think?
I would personally also say, okay, well, let's have a look at what we actually have here at the moment.
Okay. Well,
So
here, I mean, this is what we have. If we take this months out, I mean, this is our parameter to our new function.
That's actually not what I meant. If you look at the plots, if we just look at the plots that we are generating.
Okay.
So they look somewhat similar. They essentially are over time.
Oh yeah.
They are
these two are similar.
Essentially two lines.
True.
They are pretty much not the same, but very similar. So maybe we can, and also now if you look at the code, a lot of this is pretty much the same. So there is one difference between the two plots, and that's whether we have a medium, a mean line. But otherwise, those two are
it's
the
actually
same.
a part of the problem is it's actually a bit difficult now. I can see that they're similar, but it's a bit difficult for me to pick out where they're similar and where they're different.
Well, they are different in are different in which data is being plotted. They are different in the labels.
Yeah.
And they are different in the color.
Okay, so we're just, what's the next step? You tell me. What should I do?
I would create a plotting function that allows you to plot data. So probably XY data. So plot plot data XY label.
Okay. So this is the which label is this?
This would be the label for the actual line that we are plotting.
Okay, I'm going to call this line label just to be clear, because I think there might be more labels. Okay, and then what else? We've got the color, I suppose. This seems different. So everything that's different now.
Now, what we could do is so we have air temperature in degrees Celsius here, and we have a couple of times. The title is at the moment at Helsinki Airport, which is a bit inconvenient, but we could. Well, okay. Let's assume that we want to have something that essentially writes titles something at a location. So we would have a location label or a location input.
Okay.
So
we're going a bit more general than we need here, but this could be nice too. It's clear what's going on. Yeah.
That might color.
Yeah.
And that might, at least for now, probably.
And then, do we want this function to deal with the mean temperature, or are we going to do that separately?
That's an interesting question. Now, and this is a separation question, essentially. We have if I think we want to keep the we want to allow the mean to be set here, because otherwise we are essentially just recreating the matplotlib plot function, which we don't need.
So
I would have a show mean.
Show mean.
With a default false.
Y mean. I'm being very explicit with my names here, and then I'm going to make this so it's always passed in as a keyword argument, because if it's true false, I want to know what it's talking about. It's not usually clear. Okay.
Okay. So and then we are essentially we can essentially copy the code from the figure axis to the next figure axis.
Okay.
Well, or now to the figure auto FMT to this point.
Okay.
Yeah.
Okay. So I'm not going to save it. Okay.
Well, this function says plot. Not create create figures or something. This is to me, this would be a plotting function, but
this is to do with side effects, because if we write the file in our function, then it's suddenly, and it's also doing more things, and then it's got side effects. It doesn't just return something based on its inputs anymore.
Yep.
Okay.
So in this case, we are essentially instead of generate.index. So if we.
Okay. So now I'm going to call that, am I? Okay. So the x-axis is January.index, isn't it? Oh no, we need to finish writing this
yes,
first.
the x-axis.
We want to replace this January.index, which is our x-axis now. Okay. Done this here.
Yep. And put it into the x of your plot data that you are running in your for loop.
Okay, I can do this at the same time. Okay.
Yeah, because otherwise you are losing. Well, you can just cut the things that we replace.
.index. Okay, good. Okay, so I'm going to cut this.
Yep.
And I'm going to put it here.
Yep.
And I'm going to replace this with y, which is the second parameter.
Yeah, and then the label is.
We have it somewhere else here.
Yep.
Now we have
this
this
also becomes
here.
y.
This becomes y, and then I think that's it. And then location.
The label, no. So yeah, the line label is the next. So the line label would be the air temperature in degrees Celsius, and that is something that we replace.
It's not actually the line label, because we also have it's the y label. We probably want to use that there too. Y label. Let's call it y label instead. No, not location label. Okay, now I fixed it. I accidentally took the location label. And
we actually have that a third time. We have that in the title as well.
Okay. Oh yeah, but that's okay. We can call it y label.
And we can use it in there.
Use the f string again to put this inside here.
And the location label would be
the location label here.
Yeah, and now we actually don't have the value anymore to put into our input arguments for the Y label. But
yeah,
we can just
it's
say,
okay. So now I've got in my clipboard, and now here we go. I've got 2 labels to put here.
mhm,
Something and this. Whoops. And now I'm going to put in, what was this again? Air temperature. See. Okay.
okay,
And then now we got the color. So this one's red, right?
this was red, yes.
Oh, can I set word wrap on here or something?
Just you can just and that's actually what I would do anyways. You can just put in new lines.
Yeah, let's format this nicer. Okay.
So
So this
comma,
is, whoops. This is going to be red. Okay, so
and in this
yeah,
case,
now we
show
have the
Y.
show Y mean, and we want to do it for this.
Yes, exactly.
But I don't think we've implemented this yet, so let's go and implement it. So here we take the values,
We
and I think
essentially
we
have
just
an if
use it
clause.
here, and then we plot it here. So it's this bit.
Yep.
If show Y mean, then I do this bit. Okay, and now I guess
And we also need to replace in the label
Hmm.
our Y label because the air temperature. So mean.
Yeah. And so
and the color.
this should be lowercase. I didn't do the color yet. Okay. Here it's here and here. Okay.
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 And now instead of all the bunch for the precipitation.
Yeah, I didn't finish yet because I returned figure here, and then I need to get it out here.
Yeah.
Okay, now let's do it for the precipitation. So I'm gonna copy this and paste it, but I'm not gonna delete that yet. So I can look at it. I'm gonna paste this function call here, but I'm gonna start changing it to match this, right?
Yep.
Okay, so now I can put this in, and I can put this in.
Mm-hmm.
And then it's still at Helsinki Airport.
Yeah, and the color is blue.
Blue.
And the show Y mean can just be dropped. We don't need that anymore because we have the default value of false, and we don't want that.
Okay.
Okay,
So
and
now
then
I'm ready to delete this.
Yep.
Okay.
Let's
So
see.
shall we run it now?
Yep. Let's see what happens. We still have our data for the 2 months.
Okay.
And what we have achieved at the moment is that we have gotten rid of essentially one plotting block. We now don't have all these access set label, access figure, auto format the access state, and so on. We have gotten rid of that, and our actual we can of course now move this whole function into its own into its own plotting module.
Okay.
But I would say we go into a 10-minute break now.
Yes.
And
Perfect.
start this moving and additional thing after the break.
Okay.
And if you have further ideas, please write them down in the
and we'll take a look at the
CodeRefinery
notes
document
when we get back. Yeah, and that will be
but
on
also
the hour.
take your break.
Yeah, true. So we'll be back on the hour, right? On the hour.
Yep.
Okay. Bye. Hello and welcome back to the modular coding session. So in the last segment, we took a quick look at we got started with this code and we put it in this notebook. Well, first actually we talked more generally and had a bit of a discussion together with you, and then we did this, and we got as far as we've made this a function. And there's been some activity in the hedge doc. So, what do we have here?
So, Frankie, could you?
Mhm.
I'm putting in the collaborative document. Put in a small section because there was a question whether we could share the current version of the Jupyter notebook. That's essentially a little bit further down, I think.
Here.
No, further, even further
Yes.
down. Yeah, there. If you could throw the code just in there
Yeah, we
that
can paste it in for you. Where are we here?
there.
Yep. Okay,
That's
whoops.
probably the easiest. Okay.
I don't know what I've got now. What's this?
Is
this
press on the X. This
okay.
is the annotation button for this for the sharing. Okay. So let's get back. Let's get back
what
to
we had here is we had writing function for plotting different data. It's a good idea, and we kind of done that a bit, although it's not particularly for temporal precipitation, but it's essentially the idea, yeah.
Because our input essentially allows to select specific select the actual data. What would be a function that we would need or that we could do is specifying additional or allowing a user to specify the actual column that they want to plot against.
Yeah, so instead we here we take out the column that we want before we pass it in, whereas we could pass in a whole data frame, which some people might prefer that style where you pass in the data frame and then the names of columns.
But so what I think what might be worth it is in this case to actually have a function that does plot and then a specific or plot data type that essentially gives the individual value, and we in our code at the moment are actually still using January, which is wrong.
Oh, true. Month data. Yes, this is what happens if you refactor in too much of a rush, and then you don't update the names, and this is bad. So
yeah,
here it's fixed now.
But essentially, this for month in month at the moment is something that we could put into a function.
Yeah, so both of these talk about that we could have a function that deals with a bunch of months. It could be a range of months, or it could be a list of months, or
yeah. So let's define a function.
Okay.
That
should also save. Speaking of naming things, I'll save this notebook. So this is weather plots.
So and now we are actually getting into a bit of a interesting question, because up until so our function that we have produced now is essentially a pure function, because we are creating new elements. This does not modify anything that's existing. But our for loop, for example, takes the external data value. So it takes the external data frame. And that means that if we want to plot for multiple plots in one function, we need to get the data frame as an input. Because we can't now, at that point, we wouldn't be able to get the individual data points, but we would need to get the data frame, and we would need to be careful that we are actually that we are not modifying this data frame in our function. which we probably don't, but we just need to keep that in mind.
So we're going to take
So-
the data frame. So we're going to have plot, month, plot, month, and we're going to take a data frame. I'm going to call weather data, like this.
Yep.
Okay, and then I can take in a list of months, like this.
Yeah.
Okay.
And that can be one or multiple.
Oops. And I'll indent this too. Whoops. Yep. And then
you
now
would
I
need
can
to rename a couple of things.
plot months here. Yeah. Oh yeah. Now I need to call this months
This is a
lowercase
month.
because
Yes.
it's an argument now. And
And
now I've given this a slightly better name. It's weather data instead of data. Because we're
no
talking about temperature.
no.
Oh no.
This is the actual month at
Whoopsie-daisy.
the moment. That
Oh yeah, no, that's
the rest
fine.
the
Yeah.
rest is correct.
Yeah.
The rest is actually correct. Okay. And now the question is, does this plot month? So this plot month is at the moment saying, okay, I'm plotting air and air temperature and precipitation. Should we allow the plot month to also select which data needs to be plotted?
So for
And-
each data we need a
And
color.
here-
Yeah, and we need a label, and we need also the name of the column, right?
Yeah, which is either so this is the point where it becomes a bit the question, how much of this is something that should be in a function? How flexible do we want to create this? And what kind of inputs do we expect? So I think plot month is still okay. For the other stuff, so for individual what type of thing, we can do that, but I would not combine the two things.
Okay.
Because I think our plot month function here is we have a relatively clear objective of plotting air temperature and so air temperature.
So here we have something very general, really, and here we have that wouldn't even it's barely even it could be any time series except for it has to be a location. And here we have something that's just for two quantities. And as far as we know, that's all we need. So we should wait until we're asked for something more general here before we make something more general. Okay.
The only thing that we might so what I don't like about this plot month function at the moment is that I could imagine that we are looking at precipitation and air temperature things, but will our data always be at Helsinki Airport? So if our data changes, the format stays the same, but we are now looking at something else. I think that is one thing that might actually be valuable to have a location label in the plot month function.
Okay. And then we're going to start putting stuff into a library, right?
Yep. So
okay. So
and this is the point.
Here I have to put in my data, then the list of months, and then the
Helsinki Airport.
Helsinki Airport. And now I'm going to run it just to check I don't break it. Okay. So, yep. Now we're going to put it into a library.
Yeah. So now we essentially create a small subfolder that we will call plot or plotting.
I'm gonna call it my plotting lib because I want to make sure not to my name doesn't like collide with anything built in. And then I create an init, right? If I want to make a directory that's a Python module. So I always have to make this init.py.
This init essentially tells Python that this is a module and can be used as a module.
And then what else?
And then a plotting file, plotting.py.
A plotting.py file. Okay.
Yeah, and
what goes in here?
Both the functions that we have now created.
So we have this one pure function that's more general, and we have our more like domain function, which kind of wraps it to give us what we actually need. So this, yeah, and then, okay, then what do I do?
And now you from essentially in the beginning from my plotting lib dot plotting import plot month. Okay. We forgot the, yeah, we can actually, at least the matplotlib part, we can remove. The pandas we can't because that is currently still in there. So we essentially this module didn't know about matplotlib because it wasn't imported, and I would assume that if you want to run this again, you need to reload the kernel because now it has imported the stuff and.
So I have to go kernel whenever I change something in my library, I now need to restart the kernel.
Yep. Huh? Okay. And there we are.
Cool. Okay, what's next?
So one suggestion here was to add keyword arguments in the function calls, and I would second that. There's something there's something that personally I think is good coding style. Okay, it's to me it's not necessary that all the that all elements have to be set as keyword arguments, but more that when you're calling, as soon as you have more than, let's say, 2 arguments, writing down what argument is actually being meant here helps a lot in reading the function. Because now I see, okay, the weather data that's being used, the months are being used, and that's the location label. Okay. Before, especially if it gets longer, and your variable names might just get confusing, and the same probably for the plot data here.
Okay. So I think I'm okay to keep X and Y because they're very like order dependent. Yeah. But they kind of always go in the same order. But I'll put labels on the other ones. Here we have. That's a bit redundant, but we have color equals red.
Do you happen to know if there is a automatic import reload for Jupyter? I'm not entirely sure, admittedly.
I don't know. Sorry. Is that a question in the?
Yeah, that's a question or a comment question in the collaborative document, and admittedly, I'm also not sure. I nowadays rarely use Jupyter personally, but that's because I'm mostly working on larger projects that are not so much scripting side of things.
Okay, load X auto reload. So you can try and find something. We can try something like this. Why don't we just try it? Oops. So how do I insert a cell again? Yep. Yeah. I want to make that cell go up here. Yep. Okay. So now,
Okay,
no.
that was not
okay.
a magic.
We don't have it, so not this time. I'm sure maybe if you install it, you can get it working. Cool. So now let's
Okay. So what one more thing that we are doing here is we are reading in the data and adding and modifying things. And this is something where I would say this is a classical pre-processing step.
Okay.
And I would say this is something that I would put into its own function.
Okay, nice. We
can either
into its own module or function. function
Yeah.
module.
So, and here's the point. Here is where the problems start, because we now this preprocessing doesn't really have anything to do with plotting. So now the question is, do we actually have do we add another package, or do we keep this, at least for now, in the script, because it is somewhat more closely related to the actual data that we have here. These plotting things, any data that has the columns fits quite well. Not entirely sure. I would initially keep it in here, or
Okay.
we create another module package for this bit. That's also a possibility.
Okay.
But then I would probably not create it in the so create it somewhere else, not in the my
I could
plotting
call
lib,
it, well,
but
I could call it my weather lib.
yeah, okay, that
So
makes
now it's
more
now
sense.
and then under the weather lib we have plotting and we also have preprocessing.
Mhm.
Okay. And then under my weather lib. So here, plotting, plot months, and then okay. Now I'm gonna restart this.
Yeah,
'Cause
and
I've
now
got some leftover
now
stuff.
it hopefully doesn't work.
Yep. Start by making it not work. Oops. Okay.
Because
And
now
now
we we don't have the data loading. And actually,
let
the
me get rid
reading
of
the
this cell.
data is something that we don't really want to have in the preprocessing. The reading the data initially is something that we
Okay.
so, or well, then it's not preprocessing. Then it's load data, and we have another preprocess function. But
I could call it load and preprocess. It might be okay this time to.
yeah, that might be okay.
Okay. We could always split it up later.
That was the wrong one.
Whoops.
That you just replaced.
Yep. And then now from what is it called? Weather data.csv. Okay. Oops. And this needs to go in my move this from here to into my preprocessing library now. Okay, cool. So what do we think? Do we want to do a bit of command line stuff? I think we could maybe quickly.
What? Let's get it to run first.
Yeah.
We need to restart the kernel.
Yeah. Auto chestnut. Okay.
It's a bit annoying, but what can you do?
Write a command line application instead.
Yes, and that's what we will quickly do. At least, well, a little bit of things. So, if we now move this essentially into its own small file, so let's call it weather plotting or something. Weatherplotting.py. We copy this stuff over. And we will use click for this. Click is a relatively simple command line interface function that allows you to get a nice command line interface relatively quickly. So, what we essentially need is we need to have a main function. And this main function, we want to annotate with a couple of click settings. We want to tell it that this is a click command. That means annotations work with @click command. Then we want to have an @click. What options do we want? We want to have the month. Let's for now do only 1 month here. So minus minus month.
Okay. Is it like this?
Yes, and comma required true. The type is string. And we want to have give it a help function, help text that says which month, and then in year, month format.
And
Okay.
then we can also put a doc string here, which is going to be like help for the whole thing. So plot temperatures and precipitation from weather CSV.
Yeah. And we want to have one more argument, one more input argument for now, and that is the data file. Or actually, no. At the moment, we are not even adding the data file. We are just keeping the one argument for now because of time constraints. And because the functionality that we currently have is very much tied to what we have here.
Okay, so
we can add arguments for the location label and for the input file as well, but at the moment let's keep it like that. So if we now run Python minus Python just the
oops. First I'll activate my environment. And then Python.
And just the file name, whether plotting.py.
Oops.
Okay.
Oh yeah, what is it called? Is that help?
It is help.
Should this be option or argument?
Yeah, this is option. Sorry.
Option, yeah. That's get confused between that sometimes. So options are the ones minus minus, and argument are the positional arguments too.
Yeah. So okay, let's see.
Oh,
Nothing.
and then I need to add this magical thing at the bottom to actually get the main to run. I have to say if name equals main, then run main.
Yeah.
Okay.
So,
okay, so it says
now
I
it tells
can
us that
view help. Yeah.
And this tells us that we have a month which is supposed to be in a certain format and is a required for, option. So let's say month minus minus month equals 2025, well, 2024. What do we have? 2024. Let's do March minus 03. And if we now look at our folder, we have these two new files just being generated. So there are more options and how you can set them in the solution in the lecture material. Do we have any more suggestions, questions here? I don't think so. But this is essentially what we've shown now is how we can modularize this whole functionality, how we can build a command line interface or mini command line interface to just run this for individual months, and we don't need to modify the script for that. We keep the same script, we just add different command line arguments for it. And that makes this thing a whole more reusable. This could then also be added into some larger script that just calls this a couple of times. And with that, I would actually like to finish here.
Okay.
And ask Enrico to join us.
To magically appear.
He wanted to say a couple of words.
Well, first I want to say thank you, Thomas, and thank you, Frankie, for the ending mile of this CodeRefinery March 2026. And in general, thank you also to all the participants who are right now online watching us on Twitch TV, or maybe they will rewatch this later in our YouTube videos that we have uploaded, that we are uploading. A big thanks also to the team leaders. We had many local rooms this time, so greetings and thank you to all of you who were important, local partners and classroom hosts. And as I already mentioned, of course, it's not just Thomas and Frankie. There were many instructors over the past 3+3, 6 days. So thanks to all of them. All the credits to all the given parties are, and names and surnames and affiliations are listed in the course homepage. Behind the scenes, of course, there's many people who, you will never see their face, but they are there working for you, working for us. So to the streamers, Jarno, Patricia, and Gwen, who have been managing the streaming computer, and in general, the larger team that is at Alto and other places, Richard for the instructor training, and many other helpers, Michele in the Zoom, and many others. Now, when it comes to the feedback, so all feedback is of course welcome and encouraged. You have our support at CodeRefinery email address, but I highly recommend you joining the Zulip chat, yet another chat system. Zulip, you can think of Zulip as some sort of like a Slack, but a open version of Slack. And so that is like a Slack for CodeRefinery core people, but also, friends and collaborators and curious people. I don't know how many hundreds of people are there, maybe in the order of 700, but it's low, traffic. If you don't want to follow a channel, you don't follow it. And in general, you can just join, ask for help, and interact with other RSCs and, how can I call them, software enthusiasts. When it comes to the lesson materials, all the lessons are listed. If there are any issue, we use the GitHub issues that you've learned how to use. And in general, you can always, submit a pull request. Now you know how to do it and fix typos or forgotten things. I'm sure, you see we have many repositories. Basically, every lesson that you saw as a web page has its own repository. So you can create an issue or fork it and apply a patch and so on. Right. So what else do we need to mention in the keep studying and ask for support? There's a long list of different partners in different countries here. There's many links. Something for sure is relevant to your case. If your university, organization, unit, whatever wants to be added to this list, we can do it. Just get in touch. And if you scroll a little bit more down, so in general, all these places are to tell you that you can get support also from these units and from these people. Certificates. Some of you need credits for example, finishing your doctoral studies or master studies. In the link that is mentioned there, it goes to the course webpage. We have a dedicated page that explains the type of homework you need to do. The effort is low. If you've been following the 6 days, you are basically done with the homework, and then you will get the certificate. If you're at Alto, we have a dedicated course code for this. If you're not from Alto, the certificate will basically explicitly mention how many credits the certificate is valid. Maybe I can add a note that I know for sure that if you're master students in Norway, you cannot get this certificate. So sorry about that. Sorry to kill your expectations. But other master students should be fine. Doctoral students that don't have this type of issues, at least so far. Then what else? Well, in the end, support. If you want to support CodeRefinery, we are in some social media. You can, tag us if you use social media, or read our posts and stay up to date if there are other types of training that we might not directly organize, but kind of we are involved with the organizer, or some of us are organizers of other training events. So definitely some things to follow and get involved in CodeRefinery. I already mentioned the Zulip chat. You can also register to a newsletter. And maybe the last, it's kind of a satellite topic, but it's very relevant because many of us here are also part of the Nordic RSC, which is the Nordic Research Software Engineers. Nordic RSC is like a community of research software engineers, or in general, people who are enthusiastic about research software. The community is absolutely open to anyone. You don't need to, have an official title of RSC. You don't need to be employed as a research software engineer. And one thing to mention about Nordic RSC is that there's a conference coming in the beginning of June in Tromsø. So if you are a software enthusiast and want to hear some keynote speakers and take part to interesting workshops and other discussions, so head very north as possible almost, and join other research software engineers for the Nordic RSC conference. So thank you very much. It's actually 15:30 o'clock. I mean, you can say 15:30 o'clock, but you got my point. Let's have a quick look if there's anything to mention in the notes. Do we have the feedback in the notes, by the way? Yes, we have the feedback. So if you've been attending the previous days, you know the idea behind the feedback, that we kindly ask you to tell us how day 6 was, if the speed was right, if the topics were at the right level. I can tell you that every feedback that we receive is taken into account for the next round of the workshop. The next round will be at the end of September. So if you feel like taking it again, or even joining as a co-teacher or helper, or in any form you wish to join, definitely, get in touch with us. And as usual, one writes something good about the day, something that could be improved. We try to, if someone says that something was good, we try to keep that thing for the next time. The conflict, of course, is when the same thing is written under one good thing and one thing to improve. But, we will then, usually we tend to be optimistic and opt for the for the good thing. And in general, at the very bottom of the notes, there's also a feedback about not just about day 6, but about the whole workshop. So just write any notes and questions, and we will reply to the notes and then archive them and so on. Do you need anything else, or do you have anything else to say, Thomas or Frankie? Any leftover question from the notes?
I can just say that yeah, I would like to provide this. I think maybe I'm not sure how I provide this. So we have, with this lesson, we have the final solution in a kind of even better solution in the here, one possible solution. So I would actually recommend you take a look here at this model solution, which goes a tiny bit further than we did in the lesson.
The only thing this doesn't do is the modularization, not putting it into their own modules part.
True. So I guess, I don't know, I could zip that up somehow. Maybe share it somehow. Maybe I'll zip that up and just upload it somewhere and put it here in notes.
Yeah,
I think
why
that
not?
would be easiest. Okay.
Exactly. If you can do that, and then eventually, we can extend the lesson in the future if we want to add a better solution there. All right, but otherwise, thank you so much again for your teaching, and I can say that another CodeRefinery is done. See you in September, and have a lovely spring. Thank you very much.
Thanks. Bye.
Bye bye.
Bye bye.